So good morning, everyone. Please take your seat and we will begin soon. So good morning, everyone. Welcome to the sections. So today we are going to explore how mobile phone data can transform the transport planning and urban planning to understand travel patterns and all the enabling on more data-driven and evidence-based investment decisions across our DMCs. So to begin with our sections, I would like to welcome our Senior Director from Transport, Mr. Hiroyaki Yamaguchi, to give us the opening remarks. Thank you.
Thank you. Thank you, Angel. Cool. Good morning, Ms. Awanti Senaratne, Additional Secretary, Ministry of Transport, Highways, Urban Development, Sri Lanka, Ms. Sonam Choden, Executive Engineer, Department for Surface Transport, Government of Bhutan, Ravi, Matthew, all distinguished guests, colleagues, partners, and friends. It is my great pleasure to welcome you to this focus session of the Asia and the Pacific Transport Forum 26 on the topic of smart transport and urban planning using cell phone signal data. This session is very timely and highly relevant to the theme of this year's Transport Forum, from priorities to actions. Across Asia and the Pacific, countries are facing rapidly growing mobility needs, expanding cities, changing travel behavior, and increasing demand to make infrastructure investments more efficient, inclusive, resilient, and sustainable. Yet, one of the most persistent challenges in transport planning remains the availability of reliable and timely data. Traditional surveys remain variable, but they can be costly, time-consuming, limited in geographic coverage, and difficult to update regularly. Here, you know how this person trip surveys or data be organized, and then this OD trip data or those a lot. OD trip, actually, how much you can cover? A few percent, 1 or 2%, and the humongous money and the resources required for that. But the coverage only 1 or 2%, and maybe 5 years later, just a few percent more to cover. So that kind of challenges we face always. So this is where new data sources and digital technologies can make a meaningful contribution, quite a lot. The widespread use of mobile phones, combined with responsible and privacy-conscious data processing, creates new opportunities to understand mobility patterns at the population scale. Today's focus session will therefore explore a practical and operationally relevant question. How can mobile phone signal data help us plan smarter, more evidence-based transport and urban systems? Mobile app data is already commonly used, actually, in transport studies and planning reports, as you know. However, this approach quite depends on users owning smartphones with data plans, certain data plans, using particular apps, enabling location services, or belonging to specific user groups, all of which can introduce a bias. By contrast, cell phone signal data is generated through routine network interactions and isn't limited to just smartphone or data plan subscribers. Where anonymized and aggregated, it provides more comprehensive and representative insights into population movement across a broader range of income groups, especially in areas with varying app usage. This session will present the findings from the Nepal case study on deriving mobility patterns using mobile phone data, covering the approach from data collection to analysis, and demonstrating how the results can generate practical insights for transport and urban planning. The Nepal experience provides a useful reference point for discussing the broader application of this approach in ongoing and future ADB operations. I'm also pleased that today's discussions will bring together a diverse set of perspectives as invited all the distinguished guests, and then, of course, you audience from various experiences. We have colleagues from ADB, government representatives, and technical experts who will share their experience on data, methodology, planning applications, and the potential for replication across different country contexts. In this regard, I'm very much pleased that this session can also mark the formal launch of ADB's publication on harnessing mobile phone data for smarter transportation and urban planning. This publication is an important contribution to ADB's knowledge work. It demonstrates how analytical work can be connected directly to project preparation, investment design, and policy dialogue. Through the Nepal case study, the publication illustrates how mobile phone data can be processed and analyzed to generate mobility indicators that are relevant for real-world planning and investment decisions. We support our development member countries not only through financing, but also through innovation, technical expertise, and the sharing of practical solutions. It provides the replicability and scalability across the Asia-Pacific as one of the desired outcomes of today's discussions. While the Nepal case provides a foundation, the broader relevance extends to many other contexts across Asia and the Pacific. At the same time, while we discuss the opportunities, we must also recognize the importance of good governance, data quality, privacy protection, institutional capacity, and responsible use of data. The real value of digital innovation comes when technology is applied with clear development objectives, strong safeguards, and the practical understanding of local planning context. I'd like to commend the team for preparing this publication and for organizing today's session. I also extend my appreciation to the speakers, panelists, government counterparts, and technical experts who have contributed to this work and who will enrich today's discussions. And of course, appreciate the all audience joining this session today. In closing, let me emphasize that smart transport planning is not only about using more data, it is about using the right data in the right way to make better decisions for people, cities, and the economies. This publication is a step in that direction, providing evidence, practical lessons, and a platform for further collaboration. With that, I'm very pleased to officially launch this publication and to open the focus session 4 of the Asia and the Pacific Transport Forum 2026. Thank you very much, and I wish everybody a productive and engaging discussions today. Thank you.
Well, thank you, SSD, for giving us such an insightful opening remarks. So next, let me transit to the technical sections and officially welcome our speakers today. We have two speakers of today, and they will do the presentation in parallels. So the first speaker is Dr. Ravi, is the founder of the Transit Intelligence. He's an urban planner. I learned a lot from him when we prepared the publication. The next one is Mr. Matthew Webster. He is our telecom expert that we have been engaging since 5 years ago, probably, to do all the starting work in Nepal using telecom data. So can I please officially welcome the two speakers on stage? Thank you.
So we start. Because they are looking at the screen, do you want to stand on this side? Yes. Yes. Thank you. Good morning, everyone. Thanks for the great introduction, and I'm excited to present this, and thanks to the director for launching the publication. So we have some interesting insights. As the context is already set, I'd like to reinforce the point once again. So all of us, when we make decisions, so if you are purchasing our own laptop or a mobile phone or anything, so we want to have the full information about what we are getting into before we actually invest for our personal requirements. So if we extend the logic, even when we decide on transport investments, we want to know the full picture of what we are getting into so that we get the maximum value for money. And you must have seen the Asian Transport Outlook report. These are numbers from 2025. Yesterday, there were more recent numbers also, which reinforce the same point that the transport sector investments are massive. Across the Asia Pacific, in the 15-year period, there is $43 trillion of investment that is projected to meet our mobility requirements across roads, public transport, all kinds of transport sector investments. And this is 3 times what was invested previously because our demands are growing. And even within the low and middle income countries as well, the investments are as much as $2.6 trillion. So as we are investing such large amounts of money, it is imperative for us to make sure that these investments have the maximum value for money in terms of the people it benefits, the goods they transport, and so on. However, when we take decisions, like Director has already mentioned, so we have traditionally used government statistics like census or periodic surveys like economic survey or job survey that the government typically does, or some sample surveys which are typically done for the project itself. So those have inherent negatives or inherent drawbacks which can be addressed through mobile phone data. So the traditional way of doing demand estimation is that you carry out some sample survey. The typical ones, you go to households, ask 1%, 2% households how they travel, and they typically recall yesterday's trip. And a lot of times we have seen several papers publishing how people don't recall everything they did even the previous day. So for the entire city, it is very difficult to use inaccurate recall value of a sample of trips and project it for the entire city. By design, the method has a limitation. And then we have roadside surveys we do for a day or a week, and then onboard surveys on public transport to understand the routes they operate on or the OD patterns, boarding and alighting patterns. So we know these drawbacks, the high cost in every city. Just if I take Bangalore, my city, there is a mobility plan which was done in 2021. Then there is a metro DPR. For every line, there is a new DPR and new set of surveys done again. And then for a bus project, there is a separate set of surveys. When there is bus procurement, there is another set of surveys. So in one city, repetitive investments on data collection, which by design are inaccurate, are being done over the years. So they have their value, of course, and they have been serving us to some extent all these years, but we need to move to the next step going forward. So there is the drawbacks, of course, are the cost, the recall value that people have, and then the spatial resolution is also coarse. You have big picture data, not micro data. And of course, in many times there is difficulty in actually conducting these surveys also. In rural areas or in small cities, we don't even find a consultant who can actually go to the site and we are not sure whether there is accurate data. We are endlessly second guessing about the accuracy of the consultant also, and then the data. With mobile phone data, what we do is, it is first at a population scale, and it is passive data. You don't need to go somewhere and collect. It is already there. It's just we using the data that already exists at a population scale. And we can do it at a zonal level, at an urban level, at a regional level. So it's up to us to decide the level of granularity we want. And then that leads to data-driven decision making. However, it won't solve all the problems. It will solve many problems, not all of them. So some things which it may not still solve is that it will not cover 100% of it is population scale, but not 100% population scale. Because there are kids who may not have mobile phones. We hope they'll never have mobile phones. And there are elders who may not have digitized their communication. So they may still be on the old landline phones and so on. So there are some sets of population it will not cover, but it will definitely improve the overall data resolution. And it also is passive and aggregated so that we don't intrude on the privacy of the individual. So we will not get behavioral data on how a low-income person versus a higher-income person is traveling, or gender-wise, And several other user category-wise data will not be available. So for that, you still need to supplement them by in-person service. And of course, we need significant computational capability, which is a technical problem that can be solved. And we will present how we solve it. So I'll request my colleague Matthew to take over and explain the analytical piece of how to address this data. Thank you. I'll come back, so.
Right. Good morning, ladies and gentlemen. I'd like to thank SSD Yamaguchi and also the team at the ADB, including Angel Chong, Salgado Dasgupta, Rodao Bautista, and my colleague Ravi for their tireless work in launching this publication related to this focus session. I'd also like to acknowledge the Department of Surface Transport representative from Bhutan, Ms. Choden, and the Ministry of Transport, Highways, Ports and Urban Development representative, Ms. Saratni. Mobile and telecommunications networks are at the heart of the information revolution that has delivered the innovation we all know as the Internet. The ubiquitousness and general reliability of the Internet came about through careful design by the ITU, the IETF, and Third Generation Partnership Project, and mandates mobile phones follow thousands of pages of technical requirements. The requirements are designed to ensure one thing, that the world's complex networks ensure reliable communication anytime and anywhere. As a result, when a mobile phone moves, and when it doesn't move, it must communicate with the cell tower through a series of radio signaling messages, some 20,000 to 40,000 times per day. Each time this communication happens, 3 data fields, the sector, also known as the cell, the timestamp, and the subscriber identifier are generated. We take the typical location of a mobile phone in each cell as the starting point to detect trips, the trip route, and their destination. To process this data, data privacy laws are always complied with and regulatory approval granted for the purpose that is defined by the ADB project. First of all, data collection and processing is conducted inside the mobile operator's data center. This data collection uses a global innovation by Nokia, Ericsson, and Huawei called the OSS-II. I'd encourage you to look that up, which provides a standardized data collection methodology in any mobile network anywhere in the world. This respects data sovereignty, and due to the data volumes, is easier to manage. Next, the privacy principle of data minimization means only the required data fields are extracted and anonymized using the secure hash standard protocol. Finally, the origins and destinations of trip data are aggregated into spatial zones over time. To geolocate a mobile phone, we take the typical location of the phone at the cell level and use tunable algorithms that consider the geographic terrain of the country and the underlying transport links. This data provides the trip waypoints identified as yellow circles here as the mobile phone moves from one cell to another. As this data is mobile phone centric, all modes of travel are covered. Once all the trips have been detected, we count the number of trips that originate from each zone and quantify how many end up in each destination zone. In this example from Nepal's Terai region, the origin zone is 0.5 square miles in size in the center of Butwal, which is a regional town. This origin destination map shows a series of destination zones where some of them have been highlighted as they show greater destination activity. For example, more than 3,000 trips end in a zone to the south, end in a zone in a stadium that is in the south. As mobile phone data provides trip waypoints, it is possible to quantify annual average daily traffic on each road link. In Thimphu, the capital city of Bhutan, this arterial road, which is about 1.8 kilometers in length, has a small peak between 9 a.m. and 10 a.m. and again between 6 p.m. and 7 p.m. In addition, there is a daytime peak from 1 to 2 p.m., which indicates normal congestion as the average speed decreases when traffic volume increases, as you can see in the orange marker and the blue line. 50% of this volume from 1 to 2 p.m. is related to walking trips. This data is important, as my colleague Ravi will discuss later, because it is used to calculate the per capita trip rate. Mobile phone data can be used to combine origin destination data with trip volume data on a road link. In this example from Thimphu, the same road that was used in the previous slide contributes to trip volume and congestion on this link. For example, in the red zone to the right of that road link, more than 18,000 trips originate from there on average per day, while the next zone to the right, only 198 trips originate and use that road link. This knowledge could be used in evaluating public transport scheduling or other measures to mitigate congestion. In a road corridor, traffic flow is defined by how many vehicles traverse a link with a start and end point in a given hour. When an additional vehicle is introduced, this results in an increase in traffic flow and a decrease in speed. This is called normal congestion and is acceptable in a transport network. However, considering the scenario where additional demand through vehicles is added to a road corridor that is already at capacity, the impact on traffic flow is such that fewer vehicles traverse that link and their trip speeds are lower. This phenomenon, known as hypercongestion, has little value. Returning to Nepal, it is possible that normal congestion in the morning and hypercongestion in the afternoon is occurring on a major arterial road in Kathmandu. However, as a hypothesis, it could be that motorized traffic dominates in the morning, while walking steadily increases in the afternoon, that causes flow and speed to decrease. Mobile phone trip volume data on a link can be used to evaluate the impact of changing traffic volume. In this example, on a road corridor on the border of Bhutan and India, the trip volume and average speed is shown on an hourly basis. For example, from 3 to 4 p.m., there are 95 trips with an average speed of 20.03 kilometers per hour. Then, the trip volume was increased as a hypothetical test by 5%. A well-known applied traffic model then predicts that average traffic speed will decrease very slightly to just under 20 kilometers with this traffic flow increase. In conclusion, I have shown 3 ways where mobile phone data can be utilized to bring a comprehensive view of population movement. These are origin-destination matrices, traffic volume across all modes, and the spatial distribution of the origins of trips that use a particular road link. My colleague Ravi will now explore from a transport planning perspective, possible interventions in urban areas in Nepal with this data. Thank you.
Yeah, so just to summarize, so we have so far explained why it is important and how the data is processed. So the good thing is that the data comes in the same format anywhere in the world. So there is this OSSI protocol that Matthew explained. So the approach that you select in one city will apply in any other city also. So because the data is standardized, you can quickly replicate the analysis to different cities or in the same city again and again. So now we will explain how we have applied this data in the case of 3 cities for Nepal. So this is as a part of the Sustainable Urban Mobility and Electric Mobility project that ADB is developing in Nepal. So we took up 3 cities, the 3 largest, the Kathmandu Valley, Pokhara, and the LBS corridor or the Lumbini Butwal Siddharth Nagar corridor as 3 case cities for our analysis. That is to prioritize ADB investments in these cities. So just as a quick introduction, so Kathmandu Valley is a combination of 18 different municipalities, 5 million people, spread over 665 square kilometers. Pokhara is a single municipality, also spread around 500 square kilometers. The LBS is around 300,000 people. So in such large cities, 500, 600 square kilometers, for us to do sample surveys, to just identify the right locations to carry out the survey and actually implement it is quite extensive. It takes three to 6 months to carry out a good sample survey and then without bias and analyzing it. So in this case, we already had data that was collected for a highway project, which was then quickly used for this case, where we had as many as 78 million trips. That no sample survey would ever cover over the next 10 years, 78 million trips over a 2-week duration. Out of that, but the thing with mobile signals is, even if I am moving from this stage to the coffee area, it is still calculated as a trip, right? So because the mobile phone is moving, so we had to spend time screening the data. And out of that, 11.6 million trips were identified, which are within the city completely, both origin and destination, and which are not really extremely short trips, which are real trips that you have to plan for as a transport planner. And out of these, Kathmandu obviously is the bigger city, around 9.5 million, 1 million in Pokhara, another million LBS corridor. And these were aggregated at a 0.5 square mile grid. So you can also take other grids. If you can take your district map or a ward map or hexagonal grid, so whichever grid you take, you basically aggregate it at an area level. And then we can derive specific metrics that we typically use for transport planning. So the 4-5 ones which we always use in any mobility plan, DPR or a feasibility study are these. So per capita trip rate, daily trips made per passenger, per individual. Then the variation across different days of the week, variation across different hours within a given day, and the travel time of the user or trip duration, and the OD patterns, where are these trips made. So this is the basic necessity for any transport planning project, right? So we'll go one after the other, what we found out of this data. The first thing is a per capita trip rate. What we found, interestingly, is that across different days of the week and across different cities, the PCTR values were quite similar, which were between 1.6 to 1.7, which was counterintuitive actually, because the typical understanding of trip rates is that when we look at a mobility plan in a given city, around 50% are work trips, 30% are education trips. So in a bigger city with more jobs, you expect more per person trips to be made. But we found that between Kathmandu and the other two cities, even if the economic activity is lesser, the trips made is similar actually. So people may be making trips for other purposes, which we typically don't capture in a manual survey. In household surveys, people always recall the work trip, education trip, but may not be the trip they made to the grocery store or somewhere close by. So we actually got that. However, one counterfactual could be that the data we got was 2G, 3G signals, so but not the 4G signals. Maybe there are people who are using that who don't travel like this. That's a caveat, but we don't know. So that's a limitation of the study. So then we looked at travel across different days of the week. And even there, we found that the trip patterns are quite consistent. So there are specific holidays where the number of trips were lower. But on a typical Sunday in Nepal, we still had 7.8 or 9.3% of the total trips covered. So you see that across different days, the percentage of trips, of the total trips we analyzed is similar, which was also a bit counterintuitive for an external person, but people in the country were like, yeah, of course, Sundays are not holidays for schools and other things. So we got realistic data, which was useful. Then the other thing was the hourly variation within the given day, which was also counterintuitive. Typically, we expect a city to have a morning peak, then a trough, and then a peak in the evening. Interestingly, across all the three cities, we just found a single peak. The travel patterns in Nepal are such that it just peaks, stays there, and then comes down in the evening. Possibly because it is a hilly area and in the evening people don't travel as much. And 48% or 50, almost half the trips are just made in a 6-hour duration between 8 to 2 p.m. And out of that, 25% are between 9 to 12. In just 3 hours of the day, you have maximum peak. So when you're planning your services or your traffic signals or etc., so you have a clear understanding of the demand pattern, which is definitely unique for a given context. The next one we analyze is the trip duration. Around 17 to 20% of the trips across cities were really short trips or less than 15-minute trips, which you don't capture in an individual in-person survey. But again, mobile phone data got us to know this. And these are potential walk trips. Around 65% were shorter than 45 minutes, 80% shorter than 60 minutes. So the cities are compact, so they don't have really long trips within the city. So these are potential public transport or walk trips as you plan for your infrastructure, you know where to target. And the last thing is the OD pattern, which we typically use travel demand models to predict. So we have a sample survey which we project to the population scale and then calibrate as per the traffic volume. And nobody actually understands how we calibrate that. I mean, there are formulas, you click something and it calibrates and gets a OD pattern. People are happy with a good looking OD map, but we don't know whether that is accurate or not. But here we have an actual travel demand or desire line diagram for the city. And so this, of course, all these charts are at a city scale. So, but when you know in each locality where the trips are, which direction they are going, you can plan for very local infrastructure requirements also. That is transport planning, which is more tactical or short-term in nature. Then if you look at urban planning, how do you want to shape the cities going forward? Within that, what we used was 2 extra secondary data sources. So we used satellite imagery and the OpenStreetMaps data to understand where the built-up area is within the city, so that we can analyze travel data with the built-up data to understand how built form is impacting travel patterns. And we also use the population data to understand the number of people in each area of the city. So what we found, these are 3 similar looking charts. It's not supposed to be an optical illusion. They are 3 separate data items which are confirming a particular trend for us basically. So on the x-axis everywhere, what we looked at is based on the satellite imagery and the OpenStreetMaps, we got the built-up density as well as the number of buildings per square meter in each cell of the grid, that 0.5 square mile grid we took. And then we correlated that with different parameters. One is from the cell phone data, we get the trips originating and destining in a given cell. And we then correlated the travel pattern with the kind of built-up area they have. So first, just at the built-up scale, we identified that in Kathmandu, there are 30% of the city has more than 90% built-up area, whereas in the other 2 cities, it is less than 10%. So which means that it is sparse development spread across the city in the other cities, whereas in Kathmandu, we see pockets of the city which are very high dense and built up. So then as a planner, you know, either you plan for infrastructure augmentation there, or you change the building rules so that you also have development in the other parts, so that you can spread your infrastructure in other places. So but also we looked at the road density. So when you look at built up area and travel pattern versus the road density, you understand that either it is overloaded or underused. And then you can shape your city around that. So yeah, so these are separate text explaining the findings. So also in these charts, what we don't get is more granular resolution. If I'm a city planner, I don't look at it at a city level. So I want to know in each zone, how is my built up versus how is my travel pattern. So here we aggregated at a city level, but in a given ward or something, you can see this is built up, this is the infrastructure, this is the mobility pattern. And then you can either augment infrastructure or change the building rules to get more built up in a given area, less built up in another area, and so on. So this is the analysis that is done. So we want to leave with these thoughts for the rest of the discussion. So how do we use this data going forward? So is it just some data nerds obsessing about data, or can we actually use it for our day-to-day decision making? So these are our thoughts. So as a transport planner, these are 3 levels of decisions you typically take. You are either looking at a strategic long-term decision, tactical in the next 3 to 5 year kind of decision, or an operational decision on a day-to-day basis. At strategic level, the key decisions we need to take are road infrastructure development. It can be within the city or even highways. On which highway should I develop? What are the missing links? Which links need more capacity, and so on. Then the mass transit corridors within a given city or even long distance. Where should I build my commuter rail or a metro or a BRT or a city bus system? Then the urban planning zonal regulations I was just explaining on how to tweak the regulations. And at a tactical level, so within the mass transit, let's say you assume you find the corridor you want to build. Within that, where exactly should I put my station? So that a lot of times it is land driven, that wherever there is land available, you build it. Along highways, you build the corridor and so on. So you can actually specify the location so that you get maximum catchment. Then multimodal integration, because we get very local movement patterns also. So walk links to establish, cycle links and so on can be done. Then the bus route network planning is a very obvious use case, because as travel demands change, you can quickly update your OD matrix and change your bus routes over a period of time. On an operational level, there is traffic signal optimization. So we have actuated traffic controls and so on, where you are using imagery to predict the queue and then change the signal time. But even there is a lot of probability involved. So here we can have more deterministic decision making, where if you have a lot of signals, you can prioritize signals for different corridors or different directions, arms of the intersection. And scheduling of transport based on hourly demand variation, how do we change dynamically our schedules? And the congestion mitigation in the sense of corridor level planning, travel demand management kind of principles. So these are the thoughts we'd like to stop with, and then hand over back to Angel for the rest of the discussion. Thank you.
Right. So thank you, Matthew and Rafi, for giving us, of course, a very technical presentation. So for the audience, if you already have any questions, you can submit your Q&A through the app, or later on, you can also ask in person to the mic in our Q&A section. But let me also move this section ahead to our panel discussions. I would like to welcome another 2 guests today from our government counterpart to join us in the panel sections. So may I first welcome Ms. Avanti, the Additional Secretary from Transport Division from Sri Lanka. And also Ms. Sonam Chodan, the Executive Engineer from Department of Surface Transport, Bhutan. Last but not least, my colleague Sagata, our Senior Transport Specialist from the Smart Mobility team. So let me start from here, Matthew. I think every one of us is starting to turn off the mobile, the location sharing in our iPhone now. Does that stop you and Rafi tracing where we go? The mic is in the front.
Yeah, so can you hear me? So the difference is there is in every phone a radio signaling module. And as I indicated earlier, standards mandate that signaling module has to talk to the network precisely for the reason of service provision for the subscriber, whether they are doing anything with their phone or not. It's then quite critical with privacy to then, as I indicated, we always anonymize at the very beginning. We never receive the phone number or any personal information about the subscriber. And then the first thing we do is we anonymize that data so that we cannot tie it back to a person before we aggregate over space and time. So it's the population movement that is of value, not what the individual person is doing.
Thank you, Matthew. The next question is for the Ravi. Ravi, in the presentation, we learned how powerful mobile signal data can be. But there are limitations and challenges. As you have mentioned, the qualitative aspects will not be covered on that. But beyond that also, maybe with respect to that, what level of physical survey will be needed to supplement or integrate this mobile signal data? And another thing, maybe many people will be interested, that how we would like to know the people's preference with respect to mode share, whether people would like to use the cycle, NMTs, or the bus using, or maybe in case of the places where people are using rails or the metro rails. So how we would like to interpret that the modal share of this movement, how we could do this, maybe to take it to the next stage for that. And then also, based on the travel behavior, definitely we need to have some qualitative aspects. So how we could integrate this qualitative and the quantitative aspects, if you could clarify.
Thanks, Ogata. So yeah, first, whatever we presented is deterministic data, which is that we already know what is happening. However, we can only know what has already happened, not what is going to happen in the future. So when we introduce a new mode or when we build some infrastructure, we are not sure how people react to it. So in transport, we use revealed preference, stated preference data, where we are asking people how they will choose going forward when something changes. So that part will not be covered by this data. We definitely need to focus on that. And then between men and women or age categories, income categories. So because it is aggregated data, we still need in-person surveys to collect at least a sample to understand how people would react to a change that is coming to the system. The other thing is validation. So even though we are sure that this is how mobility is, but the decision maker also needs validation that it is accurate. So maybe we need some traffic volume counts to understand that whatever we found from the analysis is also accurate. The other thing we actually did not show in the presentation is the trip length distribution. So we know where the trip started, when it ended, but how it traveled through the path, we did not show in the presentation. There are ways to assign trips to the links also. And if there is more accurate data, there's always more we can do. However, even that needs validation because that is based on some algorithms that we develop. So we need to still validate some of those data points. Thank you.
Thank you. Yeah. Okay. Hello. Okay. To Madam Sonam. So I understand from the Angel and my interactions with you that you have, the Bhutan has used mobile signal data to prepare highway master plan. So based on your practical experience, we'd like to know how different it is from the conventional use of the survey, and what are the value-added component you identified when you have done, or what are the impactful planning outcome when you use this data vis-a-vis that of the conventional survey?
Almost good afternoon, everyone. Thank you for having me here. I'm Sonam Choden. I represent the Department of Surface Transport in Bhutan. So, Department of Surface Transport is the nodal agency in Bhutan who is responsible for any expansion works related to any of the surface transport. In Bhutan, currently we have about over 18,000 kilometers of roads, both motorized and non-motorized, of which the Department of Surface Transport manages almost 1,000 kilometers at present. Thanks to ADB, Bhutan now has the Highway Master Plan, Highways Connectivity Master Plan 2040, which was last updated in 2007. We thank Angel in particular, and also to the consultant, Matthew and his team, for bringing your expertise. So the Highway Master Plan 2040, it was developed using the mobile phone data. Now coming to the question, Usage of mobile phone data in the Highway Master Plan 2040, I would say, so the most immediate value was an evidence-based, a data-driven, and I would say a more holistic picture of people and goods move within the country along the different highways of Bhutan. Instead of solely relying on a conventional survey and our conventional origin destination surveys, so it reinforced the existing survey, and it provided an actual origin destination of movements of people along the highways in the country. In a way, it helped validate and in some cases even challenge some of the common assumptions of how traffic flows within the country. The analysis also provided a clearer picture of how people and goods move within different districts within the country, so which then helped highlight the key corridors of economic and social interaction. So this directly helped inform prioritization under the Bhutan Highways Connectivity Master Plan 2040. By mapping the movement intensity using all of this data, the project helped identify high demand junctions, which is really important, then stretches with heavy through movement, and potential bottlenecks along the highways in the country. Another practical outcome from the project was the derivation of the annual average daily traffic, which I'm sure the engineers, planners, and the pavement designers here would know the value of. So it's an important factor that informs designers about how much traffic a road must realistically carry over a year, which is again divided into daily fluctuations. You all know that getting average annual daily traffic correct is important. You underestimate it, and then the pavement that you designed, like it fails even before the time that you've anticipated. You overestimate it, and you over-design your infrastructure, over-design your pavement, which the countries like Bhutan with limited resources, we cannot afford to do. Additionally, the data that has been generated through the project, it's already being put to use, for instance, for the traffic analysis, for the preparatory studies of some of the important national highway projects in the country. So it's already being used by the country. All in all, the usage of mobile phone data in the Master Plan 2040 of Bhutan, it resulted in a plan that's grounded in a stronger analytical foundation, and perhaps just as valuably, it opened doors. It introduced the Department of Surface Transport officials to new analytical techniques and bigger possibilities that we have in using our data. Thank you.
Yeah, thank you, Sonam. I think when the time we are preparing for the Bhutan Highway Master Plan, we find very interesting data that we might not be observed in traditional survey, like the number of people hiking in Bhutan, climbing up the mountain. During weekend, we find all those because people are carrying mobile phone with them in the weekends. So those might be something that we might also apply to tourism or other urban infrastructure improvement. But my next question is to Ms. Awanti. I know Sri Lanka has a very ambitious plan in upgrading your public transport system. Do you know what is the data gap that you have, and how can these technologies can be replicated in your country? What is your insight on that?
Thank you, Angel. Before answering your question, I must thank ADB for giving us a chance, opportunity to highlight our aggressive, ambitious initiative in the government to transform Sri Lanka public transportation into a next level solution, because we had earlier economic crisis, health crisis, and war crisis. So afterwards, we have selected this crisis to be solved. So thank you very much. And if I answer your question, So mainly we are doing manual surveys. So based on manual surveys, we are planning and making decisions. So having continuous unavailable of having continuous OD data is the main gap which I have identified, and the ministry also have identified. Next thing is the unavailability of real-time data. Based on actually, if we take about the mobile data, we will be able to take the real-time data, especially OD, based on OD. And next thing is the fragmented data sets is the main issue in Sri Lanka, because police department is having one set of data and the RDA, Road Development Authority, is having some set of data, and some other road safety organizations are having another set of data. So that is one more thing. And next thing is logistic. Logistic actually, logistic thing is we not just haven't touched actually. So we have to have a very big set of data for logistic planning. So we have touched into that thing also based on the way Angoda multimodal logistic hub initiatives. So those are the main things what we have identified. I think that's that for the moment.
Thank you, Ms. Avanti.
Would like to supplement is that the government of Sri Lanka also quite keen to use this data for, we are coming up with the upcoming bus service improvement program. So government of Sri Lanka is quite keen to replicate the success of the Nepal. I'll not say not yet success, the lessons from the Nepal for upgrading the entire public transport system, not only with respect to the bus, maybe the paratransits also, and also maybe if possible for the railway things.
Yes, application from the Nepal is, I think it will be a very positive thing because the scenario compared with Sri Lanka situation is more similar situations, but I think it is more practical in Sri Lanka because of the geographical situation, because we have less terrain and other than central highlands. So I feel it is more practical in Sri Lanka. The next point I feel is the island-wide infrastructure coverage is very much higher in Sri Lanka when compared to Nepal situation. So the practically doing this survey will be more useful. And the next one is telecom infrastructure and penetration level is also very high in Sri Lanka. Yes, based on these things, I think it is practical, and especially I just want to highlight here one example in Sri Lanka when we are optimization and rationalization these routes. Actually, we have more requests from regional level and school students and night travel. So those we have some projects called Nisisariya, Gamisariya and Sisusariya in Sri Lanka. Those are just based on request made by people without based on the decisions based on data. So if we have such a kind of situation based on data, I think we can go for a more scientific decision making. Where the government is having a very big dream of having a digitalized transport hub at last. I think we can go forward, dream realistically that thing based on this application.
Yeah, just like to supplement in addition to the Sri Lanka also from the bus solutions or comprehensive mobility plan that we are targeting to prepare for one of the state in India. Same technology will be for preparing both comprehensive mobility plan and bus solutions. So my next questions will be with respect to Angel. One is that based on the experience of this Nepal and Bhutan as well as what we are doing, but how we could institutionalize this process in our all transport planning, whether with respect to the mobility related, whether the rail solutions, or even for the highway constructions, road construction, how we could institutionally, maybe within ADB or the institutionalize these solutions, or it is too early to take a decision on that?
Yes, so the mobile phone data introduced before our digital team in the sector department exists. So it was quite a steep learning curve when we go to the government and to suggest this type of new technology to be taken to their government planning. So of course, it's purely from an IT system, mobile phone transferred to a chance to become a chance traveling patterns, mobility patterns, and used for a study for the national-wide or city-wide transport planning. So if I could go back in time, I would make the enabling factors more easy. So I would be suggesting if we have a TA or kind of assistant to the countries or the agency to set up a dialogue between the agencies, well, no matter if it's urban development agencies or the transport agency with the telecom regulator, how this data can be transferred easily, and MOU set up legal advices, and also to, as well, to advertise this within the other government parties outside transport, so to make the best use of this data in other sectors as well. So it will become a more high-level setup, and it will benefit in a wider planning as a whole in the country. Of course, this will also lead to investment, physical investment in ADB. So we also want these evidence-based outcome to become ADB pipelines or the country pipelines that we can assist in the future. So should we open questions to the floor? If there's anybody would like to ask any question to our experts and or our government officials. Please. Do we have the mic? Oh, there's a mic in the center. Do you mind going? Thank you.
So my question is, see, this data collection through the mobile devices is an excellent way, but see, there are things like, say, in the urban context, for example, there are many buses in urban locations carrying school children, and school children are not expected to carry mobile devices. So for such things, so that is what Sogat also spoke about, that supplementing with some physical measurement and making the complete picture can be one of the solutions. But what are the possible misses under the mobile data capture be addressed through physical collection, or they are too negligible so that we can just drop them in the urban context?
Rafi, do you want to take that?
Yeah, so I mean, of course, there are things that are missing, but if you look at it the other way, are we collecting them today? So the thing is, we are not doing that even now. So for example, school trips, we understand where, I mean, in our sample, we get some school trips, but maybe their mode also, whether they're taking the school bus or a public transport bus. So sometimes it is captured, sometimes it is not. So yeah, I mean, school trips definitely is a missing part of. In terms of, I mean, what is missing? Behavioral aspects are definitely missing, like I was just mentioning. So one is, there are groups of population that are completely missing, which is a big miss. But within the captured population also, their behavioral aspects, the stated preference on how they choose a particular route or a mode or where they live. So those are things we don't know, actually. We just know that people live there. But on what basis did they choose to live there? Is that because it is close to their office, or is it because it is cheaper there, or they want to be close to the city center? So all the behavioral aspects are definitely missing, and we still need service. Yeah.
Do you want to supplement, Matthew? He seems ready.
Very good question. So Another form of data that was collected was camera data in both countries. These cameras are distributed across the country, and they record obviously a mixture of vehicle-based movement in a distributed way. Camera data can also be used for movement of individual people, children, of course, included. So the data is always independently validated against a ground truth data source for precisely this reason, for capturing children. So other data sources are needed. Yeah. Thank you.
Good afternoon. My name is Ashraf Hamid. I'm from Germany. I have basically one question, but it's in 2 layers. The first one is, technically, I can follow exactly what you're doing, and actually I can confirm it also worked in other parts of the world. But for me, it seems the main hurdle here is how to get the data. What are the governance that you have to go through? I mean, it's not really a government decision. Like when you do household survey, you go through the statistic office and they give you the layers and so on. But when you go to the mobile operator, they usually wouldn't give you this data. I mean, definitely not for free, when nobody's asking it for free, but maybe can put some insight or enlighten this part. What is your approach, or was there a government? And because it's an ADB, maybe it was much easier, which I don't really think so, because they're a private operator, they might not really care. And also on the other issue is in one of my projects, I had a problem on a regional transport. I know we're talking urban, but on a regional, and I was caught by your word that you could find some people hiking, because I exactly found the opposite. When it started getting hilly with the public transport or the informal one, there is no signal and you cannot really use anything. You just don't know what is there. So how do you fill up these gaps where you get like holes in the global south? Not only in the global south, in Germany we have a lot of holes too. So how do you fill in these gaps? So this is 2 parts, sorry.
Yeah, I would answer you how we did it in terms of our case in Nepal and Bhutan, and I will give it to Matthew to answer you about the telecom, all the regulators and stuff. So, of course, as you say, Bhutan and Nepal, we have a national kind of a SOE type of telecom company. So we do approach them. So, of course, they are majorly owned by the government. So it is easier for us to approach them to seek for their cooperation with a government project like this one. So it takes time because since the developing country, they don't even know this data exists or how to get this data out from their servers or their signal. So it takes time to process that. But luckily in both countries, we have such a condition already there, and they are willing to provide us those data for free, which is, very appreciated to the 2 telecom companies that we work with. But let me hand over to Matthew how it works maybe in your countries or with any private sector as well, in your experience.
Yeah, a very good question. I would say that the ADB play a huge role in DMCs. It becomes an open door. So on trips that are not so much detectable, in our experience, it comes down to the source data that is being collected. So we do see walking trips in the middle of the country, and the reason goes back to the sort of data that we collect through that OSS-II initiative. It's signaling messages that the mobile phone must send. In every country we've been in so far, we've been in the software's been used in the US, in Europe, as well as in Asia and down in New Zealand. The data set, the mobile coverage is quite ubiquitous, and mobile operators have in our experience, an obligation to provide coverage where people live, work, and play. Of course, they have budgetary constraints, but their coverage does seem to cover where the population is. And the next key thing is what source data are you using. There are some data sets that are slightly more aggregated and just simply won't report what the phone is doing. The signal data is kind of the key alongside. Hopefully that helps. Thanks.
Just a quick follow-up. Are you talking about one operator, or you have to go to the several operators?
Okay, I will clarify your point. In case of maybe in Nepal, also it's not only one operator, I think multiple operators they provided. In case of what we are planning for in India and the Sri Lankan case, that instead of approaching individual operator, we have asked the government to approach the regulator, telecom regulator, and collect the data from them, because it's signal data from them. Hope it clarifies your point. Instead of individual operator, it will be the regulator. You collect the data from the regular signal data from the regulator. Ravi, you would like to supplement anything?
Yeah, one additional point is that the actual signal data is massive, and what Matthew specializes in and what was presented is that can be compressed a lot for mobility applications. However, that compression requires significant server capacity. So one is the data, are they willing to provide it for free or not? Maybe because of commercial reasons, there may be a charge to it. But the bigger cost can be the server cost itself and the processing cost also. So they may be reluctant to share their own servers for us to process data for other applications. So that is something that as users we may have to invest in, apart from the cost of procuring the data as well.
So while we are waiting for the next round of questions, let me go to Sonam. So of course we have done the master plan, and you also mentioned we are using some of these data to do another project in ADB investment. So how do you actually use it, and what interesting things that you been experienced on those data, and how it justified your project in that way, that it helps you, this is prioritized in a country setup?
Thank you, Angel, for the question. The analysis that was done for the master plan project was on a network level, but it again focused on all of the networks there's there in the country, whereby we even identified some of the critical missing links that are required in the country. So the projects that I'm talking about are some of the critical links that were identified through the master plan project. So obviously the consultant and the teams that are involved, they use the traditional OD survey. But in addition to that, we all know we want all of our projects to be positive. So in order to make it positive, I would say, and to get positive outcome, what we do is we supplement those traditional, the data out of the conventional method with the mobile data that we have, which personally I have stored it in my computer from Matthew. So we provide it to the consultants who work on those specific projects, and then they use those data for traffic analysis, and then for the ultimately for generation of the economic internal rates of return for those specific projects.
Since we are waiting, maybe I have a particular question. Maybe I asked Ravi earlier, but he might have missed it. That from this mobile signal data, can we distinguish that what is the mode share of this one? How many people? Is it possible to determine the current mode share of the populations traveling?
So in the typical transport planning logic, we first ask people their modes and then derive. So we have trip generation, distribution, mode shift assignment, and then trip assignment to the links. In this case, it was the opposite, I think. So the way Matthew processed it is that based on origin destination, you assign trips also to the link, and then based on travel time, you predict what mode it could be. Also based on the speeds. So based on origin destination, and the speed of travel can also be determined. It can categorize based on speed, and we hope we got the right mode. I mean, if somebody is in a car on a long distance, they'll be faster than a two-wheeler always. But at a short distance, you may be the same mode, but we don't know. So we can categorize by that to some extent. So Matthew, if you have extra points on this.
Yeah, so in the case of Bhutan and Nepal, the transport modeler took all trips that averaged at 10 kilometers to 60 kilometers per hour, because this is generally believed to be too fast for walking, but not fast enough for flying. So they only took a subset of the trips. And then when they allocate those trips to the road link, then they're able to compare to the, as I indicated earlier, the camera data, which again is very vehicle-centric. And once they could see the trip allocation based on their software matched what the camera said distributed across the country, they know that there is a good congruence between the two. So other modes like walking at 0 to 5 kilometers per hour, are separate, and they were not included in that OD matrix, obviously for a master plan which is more focused on highways than walking. Flying is quite easy to see just because the sheer speed of movement and the distance that they also travel. Walking is also easier to see because the walking trip might only be 1 or 2 kilometers long, not 5 or 10 kilometers. So the length of trip and the speed of trip is some of the ways we use to split along with that validation. Thank you.
Please, please.
So, hi everyone, Chris Kost from the Advanced Urban Mobility Initiative. So just a quick follow-up question on the modal differentiation. So I get that it's very easy to differentiate the walking trips from the motorized trips, but how about if we're talking about two-wheelers versus bus versus car? How easy is it to tell which one we're using?
This, of course, for Ravi and Matthew. We discussed a lot on this one back then.
You can conclude. It's harder. We split the trips down to 5 kilometer per hour ranges. There is some evidence in the countries we worked in so far that trucks go a little bit slower than cars. I would suggest that this kind of be validated, through sort of more original ground truth research. So a truck going up a hill will go slower than a car. To distinguish between three-wheelers and cars, again, I would suggest some original research to make sure we're quite confident in what the speed ranges are. With cycling, we do see a lot of trips in that 5 to 10 kilometer per hour zone, which is very hard for a person to walk. So we suggest there is some evidence of cycling, but it's an ongoing topic of discussion, not a concluded one by any stretch. Thank you.
So Chris, this is not work we did, but one of my colleagues, Pratik Bansal, who is faculty at National University of Singapore. So what they did for Singapore and Seoul, 2 cities, is that they've taken the transit OD matrix from the metro agency and the bus agency, and they have, that is actual OD matrix. And from the cell phone data, they tried to map. So in public transport, you have access, in-vehicle and egress trips. So around the metro stations, if there is wait time, so the difficult thing for us to actually define is what is a trip, what is the definition of a trip. So if you are going to the bus stop, wait there for the bus and then get into the bus, are there 2 separate trips or a single trip? So we need to define the trip based on real world conditions. So where in their case, they have taken the transit OD matrix to map it against the stops and then validated it with the cell phone data to try to get the OD matrix for the transit. But within private vehicles, like I was mentioning, I don't know if we can actually differentiate between modes, between two-wheeler, three-wheeler, car. It may be a bit more difficult. Yeah.
Well, I think one message is that the mobile phone signal data is yet to resolve everything on the field, but it resolves a lot of things starting from the survey point of view and the coverage of the population. Mr. Dakar, please. Oh, he is one of our main counterpart in Nepal back then.
Thank you very much for the excellent presentation. Actually, my question goes to the Bhutanese representative. Yes, the mobile data, mobile phone signal data is excellent. It can be used in the existing networks improvement. And in the urban context, it is useful. But you told you have used this in the highway master plan preparations. Yeah, there might be a number of critical sections. There might be a number of new sections to be identified. So this data is able to predict the diverted traffic. Is there any traffic assignment or behavior study model is required? That is my question.
Thank you so much for the question. For the technicalities, I would request Matthew and Ravi to please supplement because I do not know the technicalities of how it works. But to answer your question, the mobile phone data that was used, so it was like the origin destination survey was done using the mobile phone data. Then another transport modeling software, or I would say a technique was used called Transcat. So that was used to model the movement and also like possible bypasses or possible new highways that we might require. For instance, when I mentioned about one of the critical missing links along the highway, so at present, Bhutan uses the Indian highway like on to our southern border, and we do not have the links from within the country, or we need to detour like very long routes in order to get from one destination to another. So through the analysis that was done from the master plan project, so we realized that having constructed a missing link, one of the missing links could help divert the traffic that goes into the Indian side of the border into the country. So I would say that was an important aspect out of the project.
Yeah, it will save me another 13 hours because I was a foreigner. I was not as easy as the Bhutanese or Indian. I can cross the border easily. So I need to travel 13 hours because of that missing link. And that's how come how justifiable is the project needs to be there. And of course, we also see emergencies because, during COVID, the border is closed. Yes. Bhutanese cannot travel to India either. So this is also an emergency supply chain issues in the country. So these are all justified and shown in our master plan and all the mobile phone data, how people actually move, and give a strong justification why government need to invest in that project and how urgent it is. What if a next pandemic comes again? So while we are also waiting for another questions, okay, good. Oh, we have two, so maybe one after each. Thank you.
Yes, actually, this is really impressive to hear about the mobile using mobile phone signal data converting to our decision making. So what I want to know is now here mobile phone data. How are we now? As you said, we can't do the vehicle classification. Then how are we going to correlate to the software Transcat, either Transcat or JICA Strada? Because after that, for the master plan, we need to run the Transcat and the master plan. How are we going to correlate without vehicle classification into that software?
Do you want to answer? Okay, well, maybe Matthew first and then.
So the camera data that was collected in both countries split into different vehicle types. So because we show the total number of motorized trips on a particular link. They then use the camera data to split those trips into the different modes. So the camera is telling you the truth. You know, this is a truck, three-wheelers, two-wheelers, cars, motorbikes. So as a combination of the camera data that then splits the trips that was provided by the mobile phone total trip volume. If that's how it was done by the consultant. Thank you.
So, ma'am, in Transcad, the output is what you get here directly. So, what do you get at the end of trip assignment and calibration? You get a traffic flow which is calibrated to actual conditions, which is what this already does. So what happens in Transcad? You have sample trip generation, distribution, and the trip distribution, all the impedance factors, nobody knows how they actually work. And you keep randomly doing trial and error with those values, and you estimate the OD matrix. And then you have traffic volume counts, and you give traffic volume counts at certain intersections, and you do the OD matrix estimation. I mean, whether it is Transcad, Visum, whatever software you use. So there are several levels of assumptions or predictions based on which you get to trip assignment and calibrated flows. Here we actually get the calibrated flows based on real world data. Then you calibrate the model for this data rather than changing, basically getting the model as an output. Based on this data, you change the model and then do your horizon year projection. The future projections can be based on this output. So basically, you have to inverse the decision-making process, if that makes sense. Yeah. You have applied it also. Do you want to add something?
No, I did not.
You did not.
Well, just to supplement a bit is that we still need to some field study to understanding the mixture of vehicle types and to overlay on these data, and to predict for the future. Of course, we are not only saying that these are the only two guys who planned. We also have economists, transport economists, adding all these GDP factors and assumptions to predict what is in the next future, what we have to do in the future. So, of course, these two guys play a very important role, but we have a big team at the background to do all the analysis and assumptions. Yeah, of course, the government also needs to contribute what is their plans, their master plan or their, visions for the future. These has to be contributed into all these study analysis. I think we have one more question, right? Thank you.
Sorry, my name is Mustaqim from Indonesia. I have want to go through how far this research can go. The first, if we talk about the regional transportation, might be the first we can separate based on the location. If we have the corridor for the railway, we can just separate the signal for the railway, for the national way, and also for the toll road. That's the first. The second, if we talk about more detail, for example, for the urban, in Indonesia, especially in Jakarta, we have the dedicated lane for the bus, we have the lane for the LRT, MRT, metro, and for the national or the local road. In your presentation, I think the area of the node or the cell is about 0.5 miles, right? How far can we go into detail? Therefore, in urban area, we can do the separation in the area as well, especially if we have this dedicated lane for the bus, or even though if we can have the 3D data for this cell phone, we can separate with the LRT that we built in the, not at grade, not in the same level with the road. How far can we go with this? So we can have those different data, so we can easily analyze which one that go for the railway, which one go for the dedicated lane, which one go for the road, which one go with the LRT and others. Thank you.
Thank you for the question. So in the countries we've been in, we generally go to around 300 or 400 meters of accuracy. We also, where the data is available, we rely on the General Transit Data Feed, the GTFS feed specification. That actually tells you the bus routes and the stops and the timetable. And then we would align the mobile phone trips that follow the same timetable and literally the same latitude, longitude pairs to align it to the bus route. So it's a combination of, you know, those two aspects, the level we go down to, as well as aligning to other data feeds to tell you about those types of different modes, which is different to vehicles. Yeah.
Yeah, I think we are almost at the closing. So, well, we welcome all the audience to approach to our experts and our government counterpart here. But before we end, I have one more final questions to Ms. Awanti. You know, as a pioneer to your country, having these new technologies to the country and use it in transport planning, can you give us maybe in 1 or 2 sentences how you're going back and convince your government to widely adopt it into your, you know, into your department?
Difficult question. Okay. Anyway, we are under the theme of priorities to action under ADB. So government is also at the similar level of thinking. So we have identified some priorities and we are at the process of putting them into actions. So actually nothing to convince this thing, because it is already identified by at the level of policymakers. So that is what I told. Actually, it's a big dream having in our minister's mind to have a digitalized transport center at the end of maybe 3 to 5 years. That is the way forward that they have identified. So I think I don't have anything to do to convince them. And I just want to be aligned with that and help ADB, maybe other development partners and the government to go align with that. Okay, thank you.
Yeah, I think, ma'am, only thing we need to do, map the process and complete the activities and ensure that the data are available on time. That's all. Thank you.
Yeah, thank you all the panelists here. So we are closing our section. So we want to invite our Director of Transport from our Smart Mobility team, Mr. Lakai Sang, to give our closing remarks. Thank you.
Okay, thank you, Angel. And thank you very much, all of you, the panelists, and all the audience for a very insightful discussions, including data collection from mobile operator or regulators, also transport mode sharing, application of this model to the master plan. So there are a lot of good discussion being held here. Thank you very much. And also, I recall maybe 4 or 5 years ago, I met with some of the panelists in ADB. They propose new initiatives to utilize the mobile data to make some transport, traffic assessment, demand assessment. At that time, we had some same kind of discussions, like, the difficulty getting kind of mobile data from the mobile operators, or maybe sometimes how we can divide the transport modes from that kind of data. We have some discussions also at that time, but the team have been improving the model. And finally, that kind of, get some certain models already achieved. Appreciate the effort of the team to reach this point. Still, the model needs to be a bit adjusted or refined, but the huge advantages of this mobile data model to make assessment. So this session reinforces a simple but important point. Good transport, the planning depends on good data. That's really real world. Without a kind of good data, we cannot make any decision about investment. In many of our developing member countries where the population is increasing very rapidly, particularly in urban areas, the infrastructure resources remain limited, and weak data leads to inefficient investment or maybe misallocation. Traditional survey-based methods like a person trip surveys are very valuable, but also very expensive, and simply unable to keep pace with that change in travel patterns or increasing the city we are witnessing across the region. The result too often is infrastructure that is either undersized, misallocated, or planned on assumptions that do not reflect how people actually move. So actual accurate data is very important for investment decision. Mobile phone data offers a fundamentally different starting point. As mentioned in the beginning, it is passive, population scale, and the continuous. As discussed in the session, careful data engineering can translate these into actionable planning intelligence, including trip rates, origin OD kind of matrices, congestion patterns, and the relationship between urban form and mobility demand. Several findings and ways forward emerged from the very productive discussions. The first is the travel demand patterns in developing and emerging cities do not always mirror the textbook model. Planning based on the borrowed assumptions from the high-income city context risks getting the decision wrong from the outset. Second, travel demand is highly concentrated in space across different urban contexts, large metropolitan areas, mid-sized cities, and smaller corridor towns. A disproportional share of trips originate from a relatively small share of built-up areas. This has a direct implication for investment prioritization, targeted density sensitive, and deployment of infrastructure and public transport services can meet the majority of demand at a fraction of the cost of network-wide approaches. Also, this dynamic nature of data will help not only planning, but also establishing robust decision support system. And thirdly, methodology and technology discussed here are replicable and scalable. The data engineering documented in the work from new telecommunications signal data through a geo-enrichment, privacy protected, bias corrected, and trip derivation is not unique to one geography. With the mobile penetration rising across the country, across the Asia and the Pacific, across the world, and then with the growing ecosystem of telecom data providers and analytics platforms. This approach can be systematically deployed across ADB's developing member countries. So we are very much hoping that the methodology here could be applied to the other countries and the regions as well. However, there are, of course, we have discussion, some issues, some challenges here and there. We discussed access to data remains a significant institutional barrier, particularly in some countries. Engaging regulators and operators, genuine partners in data sharing is really essential for this model. And the computational requirements are non-trivial, particularly for lower capacity government agencies. But direction is clear. Technology is progressing. We have to use that kind of technologies. We cannot stay in the same position. As networks expanded, as data governance frameworks mature, and the governments build internal capacity to mobility analytics, these barriers will fall. ADB is already seeing this in South Asian region, as explained in the discussions. For us at ADB, as a development agency, the message also very clear. We need to move from proof of concept to practical application of this model to every aspect of transport planning. That means working with governments to institutionalize mobile data as a standard input to transport master plans and urban development strategies, even though we need some adjustments still, but that could be quite important. It means investing in government capacity, data literacy, analytics skills, and institutional framework to sustain this over the time. This also means working with telecom regulators to ensure that data which already exists can be made available for planning and operational purposes. This is fundamentally a policy issue and not a technical constraint, but ADB happy to support that kind of arrangement as a development partners with the government. Finally, I want to extend my appreciation to the authors of this knowledge product and the session organizers. This is the kind of work that can help ADB further strengthen its role as a trusted development partner, combining operational experience, knowledge solution, and practical innovation to support its developing member countries. Thank you very much.
Thank you, Nakai-san. So thank you all the panelists and my colleagues, and also Sonam and Ms. Awanti here to share out the panel discussion with us. So yeah, we will end our sections here. Thank you everyone for attending this, but you're also welcome to come in front to speak to any one of us. Thank you very much. Maybe a group picture first, and I will ask you to. Yeah, maybe we do the group picture with.
Group picture. Okay.
Sorry, I will do it.
Yeah. As well.